Hi folks, and welcome to part 2 of the Dansette Major, which I think we will call Anita, given that it's signed by Anita. Why not, eh? Yeah. Anyway, it's time to remove the chassis. So we'll first disconnect the speaker, and I'll disconnect it from the transformer. There we go, there's one off. I don't have too many wires dangling around then, you see. And they're both the same colour, so it doesn't matter which one goes where, because it's mono. So power lead's got to be replaced. I need to find a power cord for that. Need to find a Dansette upgrade kit. Yeah, find a Dansette upgrade kit. Get the screws out. I was glad I got them knobs off without breaking them. I really truly was, because that would have been a real shame. That would have really annoyed me. It probably wouldn't have made Phil happy either, but it would have really annoyed me, because this thing is actually, you know, really nice. And it wouldn't have been very nice to have to tell him that, hang on a minute, that I've broken his knobs. I was just replying to a friend of mine there, folks. Right. I hope there's no screws on the bottom there where the No, I can't see there being any screws on the bottom. How would you get them in? And I'll tell you something else, folks, this has never been worked on. And I'll tell you how I know, because it's completely original. You can tell that when you're a repairer. Automatically know. And this just pulls out, and there we have Anita's amplifier that she built all them years ago. Right, let's put the screws for the case in here. There we go. Remember, just going to leave the knobs in here for now. We can put the case away now. Be back in a minute, folks. Right, well, I think it's time to put the case away. I'll just put it down here for now, out of the way, so we can take a closer look at the amplifier and see. There's another case screw. Just drop it in through the knob hole. There we are. Just put the case down here for now, and I'll be back in a minute, folks, and we can take a good look at the amplifier and do some checks. Right, let's have a look at the amplifier. Right, this is a very simple, what we call a one valve wonder. It's actually very well made. There is a blob of solder down there, actually. Anita, you naughty person, look. That's been down there all them years, but it's got to come out. There we go, look at that. Anybody want to buy a blob of vintage Dansette solder? This is real Dansette solder. I can afford it, and it was left here by a woman called Anita. It must have dropped off her iron. There we go. I only want £300. It's not a lot. Right, I need to work out how to get this bloody valve. Out, really. It'd be nice to... I don't want to break the fucker. It'd be nice to get it out of the way. I mean... Yes. Right. Well, we've got the ring off. Now let's see about getting. There we are. You know something, folks? It's like defusing a goddamn bomb. But look at this. A Mullard EL84, and do you know something? It's not overheated or anything. The pins are lovely and clean and everything on it, apart from a bit of dust. There we go. Let's put that safe, because that'll be going back in. Bear with me, folks. There we go. Right. So what we need to do next is we need to disconnect the on and off from, just take the remains of this main, well I won't take it off, I'll snip it off so I know what side they connect to, because you can easily forget. I don't suppose it matters, but well it does, doesn't it? And these can go anywhere. They only go into the transformer. I'll get that in a minute. Let's get this. Let's get me soldering iron cleaner. Yeah, I went to Aldi earlier. I ran out of dog food. Yeah, I need something to eat. Yeah, so you know, basically what I want to do is take the transformer out so that I can get to the board. I've got to anyway to get to the board. And you know, this is gonna be super easy to put a rectifier in. I'll show you why in a minute. Right, so basically what we need to do next is these wires do they go into the transformer or are they soldered onto the outside? Them ones go in, these ones are soldered to the outside. So we'll snip that because that's the blue for the recce, it's a negative. So we'll snip that just so to avoid confusion later. And we'll snip this one here because we're going to put a silicon diode in here. So we'll snip that and we know where we're up to, because we're going to get shut of the rectifier. We're going to get shut of that right now as it happens because it is of no practical use. We want more efficiency. We're living in the world of the meal in 10 seconds. So why should we put with a rectifier that can't be efficient? So let's get rid of that. Right, I've got this lady who keeps wanting to chat to me, and I don't mind. I just don't want that writing to come off there, and it's written on in pencil. I'm afraid it might. So the next thing is to take out the transformer. think that name's gonna stay on there because it's written in pencil and there's nothing I can do. By the time I'm done, I'll have my hands all over it. But you know. It was put together well anyway, that's for certain. You know. Alright, comes apart nice and easily now. Whoop. Yeah, my screw, my nut was stuck in me. Yeah, my nut is stuck in me nut driver. It's not really a nut driver, but it does the job. My nut is stuck in me driver, so we'll do that and pull it out. Hey, you know why Frankenstein can't have kids, don't you? He's got his nuts in his neck. Anyway, we've got this one here, which I suspect is the heaters, and these are grounds. This is chassis ground and heater ground, so we'll just snip that. So this is chassis ground and heaters and stuff. So we'll get rid of that, and we'll get rid of that. We'll snip this here, and we know where that goes. Put the transformer out of the way. There we go. So that's the transformer out of Anita. We'll leave these wires as they are. This goes through to one of the valve sockets. I'll tell you what, you know, this board is nice. It's actually nice and clean. There's a bit of a ball of fluff there, but what can you expect? Well, this is lovely and clean, and it's, you know, it would be nice if it'd be nice if that can there's in good nick, because if it is, it can stay in, because otherwise I'll have to order replacements and that puts it on hold. Oh, I nearly missed my mouth then. You're probably all wondering, how can you miss something that big? But I don't want to put it on hold, so I'd rather, I'm just hoping it's going to be okay. Ooh, I think we've got a bit of a dry joint going on there. Don't think it would have affected it, is it? No. Yeah, just a little bit of a dry joint there. But I'm going to go over it anyway. But this is this is your tone control here. This is your tone control. Goes to your tone correction capacitor, which is this thing here, and also goes up to your output transformer. That's, pardon me, at some point. This is your volume, which has your output and goes to your valve, and that's where we have a dry joint here. So if this had any problems, it was probably that pin that was loose that was causing it. Hang on a minute, folks. Oh. I'll tell you what, it's a good job arseholes don't wear out, innit? I'd have to go and get a replacement. You know, some people think farting's rude, you know, but it's not. I mean, how can anything natural be rude? You know, and it could be argued, well, you're doing it on video. Of course I am. If I weren't doing it on video, I'd be doing it somewhere else. I'd still be farting. You know, it don't bother me. I mean, I've always said, you know, farts are like kids. You can only put up with your own. I'm going to have a smoke and, you know, going to have a smoke and get the ESR tester and test that smoother. I'm going to test it in circuit. I'm not going to test it out of circuit, and I'll test them 2 resistors. I would imagine they'll be okay. I mean, I can't believe how good that DANSETTE tempo turned out, considering I was talking to Phil on the phone earlier, and you know, he's got some more for me to do, so you know, it's always welcome. Brilliant. And we've got 2 more jobs that are here to do for him. We've got that DANSETTE RG31, which I'm hoping is going to be perhaps not tomorrow night, but maybe the night after, because it'll probably take me a couple of days to do this one. I mean, I can turn them round in a couple of days. Just trying to think when my frigging lighter is. Do you know, if it had airs round it, wouldn't have any problem finding it, would I? Right, get the old giglets back on and get back into this. Now, right, so we need to clean the switches, well, the controls, potentiometers, we need to clean those, and we need to find a power cord. That's not to worry about that just yet. You know, this is all labelled as well, you know. Your heaters are here, which is pin 4 and 5. This is your HT here, which goes off to your anode somewhere. This is your HT in here. Your heaters are here. I would imagine that's your negative, your ground for your heaters, because heaters on an EL84 are 4 and 5. And this pin here isn't used unless there's something on the top of the board, which there isn't. So that pin there, although it's soldered in, isn't used. So your heaters has got to be here. I'm assuming that your anode. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm not sure what pin the anode is, I can't remember offhand. I should know, but I don't. It's in the manual. Let's have a look at the value of this can. It'll be the same as the other one. It's 25, it's 32, 16 and 25. And the ring is negative. Right, so it's 32 is the square, the triangle is 16 and blank is 25. And I can connect anywhere for the ground. And it's 275 volts. The capacitor, except for the 25 volts, 25 microfarad one is 25 volts, so I can replace that if it's gone. But I'd rather not replace any of it actually. I'd rather, you know, why recap if there's no need? You know, like Shango's always saying, Shango 066, you know. You know, people think the recapping is the beginning and end all. You know, and it isn't. Why throw good money away? Putting in parts that you don't have to, that are not needed. I mean, I'll guarantee it for Phil anyway, I guarantee all my repairs. So, why is there a wire going in there? Look at that there. You know, I guarantee all my repairs. So, if there is a problem, then he can come back to me at a later date and I'll do it, even if I haven't replaced the part. I guarantee the machine. With the exception of the transformers, that is, because you can't get them. Not without a lot of pissing about, but yeah, I'd guarantee the capacitor if it was my choice to leave it in. But let's see if we can test this without pulling it. So we need to connect to the negative, which we can connect to the chassis for the negative. Can I get the meter on before it goes off, times out? Oh, hang on. 46.7. That'll be the what do you call it, the 32 one. That's not bad. I've seen worse, a lot worse, and it's only 0.53 ohm ESR. That's okay. Hang on. In circuit leaky. That one's saying in circuit leaky, but it's reading and it's giving an ESR reading, so I'll have to pull it and check. And that's 17.1. He's 8. That's 16 microfarad. Is 18. So it's up a little bit, but it's 150 ohms ESR. Let's try this one again. Where are we connected to here? We're connected to a valve, and we're connected to the valve, and there's nothing in there. So unless it's this one here. Yeah. Oh, that's 14.3 ohms. And it's saying in circuit leaky. I'm going to have to take it out and test this. Yeah, we're going to have to pull this capacitor, I'm afraid, and test it. It's a shame. Oh well. Let's get the old sucker, the old solder sucker. Who wants to sucker? I don't want to sucker. No. Let's find something I can prop this up on. Let's use the transformer, if it will do it. No, it's too high. I need something a bit lower. Be nice to have. I'll just do it this way. Right, let's get this desoldered. That's a negative, that one actually. Yeah, it is. That's a negative. That's why it's. Yeah, that's negative, that one. That's the ring. Because it's the widest out of the lot. Hey, did you ever watch that film, folks? The Ring. I thought it was about somebody's ass. You know, I thought it was about somebody's ring piece. I remember when I was a kid. I watched that film at Grand Prix. At Grand Prix. I thought it was a porno. I thought it was called Grand Prix. I don't understand that. You know how anybody can sit there watching pornography. I can't do it. In all honesty. I mean, there's many things I can stomach, but that's not one of them. Not one of my vices, I'm afraid. Yeah, I'm a doer, not a watcher. And this won't stand up on here. It won't stand up on here, and I'm not taking anything else off the chassis because nothing else has to come off. Tell you what, I'll use my ingenuity, because I'm not taking anything off the chassis that I don't have to take off. So what we'll do, we'll put that there, and not that one. Where's the pipe? Where's the spiky one? Not that one. Where's my hooker? There it is, my sticker inner rather. Push that into there. There we are. There you go. Sticks exactly where you need it. That's your sticker inner, or your sticker upper, or your pusher inner. Yeah, this is. There we go. Get as much of the solder out as I can. See, if I have to order new parts, then I will, but I mean, there we go. Right, let's give this one a bit of a, see if we can, where's me, let's get me. There we go. I mean, these have been in here for years. I mean, that one, that pin's actually snapped off, but that doesn't matter. I mean, they will snap off because you can't get the damn things out. Clean the hole. There we go. And the big wide pins like that one won't snap. Don't have to anyway. It's straight. That's got that nicely. So we've got that. We've got that. See what else we've got sticking in here. That one there needs to come up. I think that one's bent over and all. I mean, if the move that anode pin out of the way, that rectifier pin out of the way. Graham! Right. That was my friend Graham on the phone, not to be confused with Radio Cruncher. It was my friend Poker Graham, or as I call him, Eeyore. Because when he answers the phone, he goes, hello. Sounds like Eeyore out of Winnie the Pooh. You know, the dopey donkey. Or the miserable donkey. Always sounds miserable, Eeyore, doesn't he? But, yeah, I'm going to reflow all these joints on this. Because, to be perfectly honest with you, I'm not really happy with them. I mean, we're dealing with an amplifier here that's 60 odd years. Scraps! We're dealing with an amplifier here that's 60 odd years old, so of course it's not going to be perfect. You don't expect it to be. Not at that age. I won't be perfect when I get to 60. I'm not perfect now and I'm 53. Right, is that just a blob of solder, or is it? No, that's a part of the capacitor. Get that desoldered. Well, would help if I pushed the plunger down, wouldn't it? So you want to get it loose, I'll be able to jiggle them out. Right, what about there? Yeah, that one there has to be done. I'll tell you what, I love working on these old amplifiers. You know, they were really, some of them were really nicely made. There we are. I mean, there we go. There we go, we're out. And we never lifted a pad. Didn't damage any pads. Now, let's get the crap off the top of the capacitor. I don't have to worry, oh, that's part of the capacitor. Yeah, it's part of it, part of the silver foil inside. It's not leaked or anything. Anyway, let's test it. Because if it's okay, it can go back in. I mean, this tester is supposed to test in circuit, but it doesn't always. I mean, you can forgive it that. I mean, but the company who make this, Pt2, I mean, it's a really, really good company to deal with. I mean, I've dealt with them on numerous occasions, never had a problem. 49, and that's 133 ohms. Sorry, 1.35 ohms. My mistake. Hang on, there we go. 19. 160 ohms. And that one's 46 ohms at 15, that's 46 microfarad at 0.38 ohms. So let's go over them again. So that one is 49 microfarads, that is. That one's 90, yeah, it's a bit out of spec, that. And that one is, let's have a look at the symbols. It's supposed to show you some symbols on here, so you know what's what. It shows you the symbols. Oh, hang on. It doesn't show you anything on here. It tells you what they're supposed to be, but it doesn't show you the symbols. Wonder if they've worn off. Well, they can't have worn off. No one's been near this. But yeah. Oh, hang on. No. Doesn't show you. Right, so. Well, we're out of tolerance on it anyway, so I'm going to have to order some. So I'm going to replace it anyway, because I haven't got any in for stock. I don't think. I'll have to check. Made in England. But saying that, you know, it's saying that, you know, it's old, isn't it? And it's been in there all them years. So at the end of the day, we can order up a new capacitor for it, or 3 separate ones. I will actually check my stock. If you bear with me, folks, I'll check my stock. If not, then we're looking at another part. Right, I've just had a closer look at this, and this one here is the square, which should be 32. So let's go over it again. This one here should be the square, which should be. I'll make a drawing of this because you can't really see the marks. I had to really look. So this one here is the square. That one's the square. Which is double the value it should be. It should be 25. No, it's not. It's just it's actually 46.20 microfarads. So it's nearly 47 microfarads, it's approaching that. And this one here, oh hang on, that's the ground. This next one is the blank, as they call it. And that one's saying in circuit leaky, but I think that's me. And the blank is 16 microfarad. Oh sorry, the blank is 25 microfarad. And that's almost double. That's, you may as well call it 50 microfarad, that one. And it's 49.60 UF, that's well over. And this one is the 16 microfarad, which is 19.16 microfarad. And so I'm going to have to replace. So what we need to do is pause you for a minute and I'll have a look in stock, see if I've got them. If I'll have the 25 volt one. I'll have the 25 at 25 volts. I'll have that, but it's the rest of them, the other two. Let's see if I've got them. I'll be back in a minute. Hi folks, I'm back and I've managed to find, I thought I was going to have to order them, but I've managed to find in stock the correct capacity, well near enough the correct capacitors, they'll do the job. I've got oh hang on, that's the wrong one, forget that one. I've got a 10 UF at 400 volt, that'll do the 16 microfarad one, it's only 6 microfarad less. But it might even be a bit more on that 10, so we'll check it. And I've got a 47 microfarad at 450 volts, which will do the 32 microfarad one. So I just need to find a 25 microfarad. I thought I'd got on, and I might have one. Is this one? That's not one, is it? No, I've just looked at that, haven't I? Yeah, 470. I thought I'd got one out, but obviously. Oh, hang on. Well, I did have one. I'm sure that's one. I think that's the. I don't know what value that one is. But let's have a shufty. Right. This one is. 50 volts at 22. Let me just put my magnifier on to just make sure it's a 22 and not a 2.2. So that's a 25 volts. And that's what we need. Right. Just I'll take my glasses off a minute. Yeah, 22 UF at 50 volts. So that'll do the 25 volt one. This one will do the 16 UF at 400 volts. And this one will do the 32 at then this one's a 47, so this is just under 50. It'll do. It will work, no problem. So while I've got the magnifier on, just tighten it up a bit. It's better. While I've got the magnifier on, I can look at this. I can examine this more closely, find out which is the triangle, which is the square. Right, so That one is the triangle. Let's have a look at the... Right, so let me get my marker so I can mark the bloody thing. Got something to mark it with. Where's my magic marker I had out last night? But if I've got any brains, I'll have thrown it back in my drawer. Yeah, it's here. Right, so that one is the triangle. That one is blank, so we'll put an O there. And that one there is the square. So we'll put a line there, and we'll put another line there, and there we go. And that's the square. So triangle. So square, triangle and blank. Right, so now we know where we're up to. Put my marker back in my drawer. As I highly suggest that if you know, doing this, get one of these. Because they also have a light on them as well. Look at that. Get one of them. You might not use it often, but when you do, it comes into its own. So let's have a look at which way this thing went in. It can only go, well, it can go any fucking way, to be honest. But let's have a look at, well, actually it can't. It can't because two pins are narrow and one's wide. So the wide one is that. That's the wide one. So it goes there, and that's the way it was in the amp, because I could read the word daily while it was in the amp. So if I pull it out, turn it completely upside down, turn it completely upside down, just make sure I've got this right, because I don't want to put the wrong ones in the wrong places. So the top one's a square, the bottom one there to the bottom left is not, that's blank. Hang on. Yeah, because they're two small holes where they went through, and so the top one is square, the bottom one is blank, and the top one is triangle. So what we need to do is make up our capacitor. So basically, that's the negative. Negatives will all be tied together. Negative. Let's move this out of the way a minute because I don't need this at this point. Negative, negative. Whoops. Right. So negative, negative. I want to keep them all pretty much the same height. Right, let's give that a twist. Get a good mechanical connection. Oh, I've got a frog in my throat. Takes some winding getting this in, but it goes in. That's that one. And then this one is our 25 at 20, 22 at 25. But this is a 50. And that's positive. And that one there is negative. And all we do is we join all the negatives, move the positive. I mean, to be honest with you, that's a bit close. Yeah, it's a bit close, that. So I'm going to move that like that. And I just read a sort of a comment from someone on saying that names were common to be found in them. I mean, yeah, they probably were, but you know, it's the first time I've ever actually found one. I've found a few dates, you know, found a few dates and times and stuff like that, but I've never actually found you know, just never have. So what we'll do, we'll fold that over so we're not touching anything, because I'll solder a wire on to become the negative. So that's all positives there now, they're all negatives connected temporarily. What I want to do is put that, or basically get it as near as I can without it touching anything, so that we can get this one as near as possible. There we go. That will do it. Now all I do is solder these three together, the negatives of them, and then we're cooking with gas, and we can start putting parts in. And I will be double checking because of different voltage. I mean, last night I didn't have to double check, I used all the same value and all the same voltages, so I didn't have to worry. But because these are different, I will be checking the values. That's nice. There we go. Now let's get a piece of wire to solder on as a negative. And got a piece here. Will do fine. I did have actually a nice piece of black wire last night. Don't know where that went. But I had a nice piece of black wire which was braided. Well, not braided, it was, you know, sort of braided, sort of pre-tinned if you like, in the installation. And I used it. I can't think where I put it, but never mind, this piece will do. Piece of this will do. Just clip off the clip off the shitty end. There we go. There we go. And clip this. So we've got a fairly long piece, because it will be going through the board and it'll be connecting all the grounds up. If I feed that through there, I'm going to check the ESR and everything on these. I would imagine they're better than what's in there, than what was in there originally. I mean, they've got to be on the brand new components. Lift that up a little bit. Get my wire under it. Push it down to get the mechanical connection that we want. There we go. Take our soldering iron. Solder it on. I didn't bother tinning it, there's no point because it will tin it automatically as it solders on anyway. There we are. That's the ground sorted, and I will put some heat sheathing on these, I think, but we'll see, because I will need to bend them into the correct orientation. So, and especially that little one, yeah, I think I will put some heat shrink on them. Now let's check the ESR of them, check the value. I've already made the capacitor block up, so we'll just check it. We'll just bare that wire, because that'll be going through the board. There we go. Turn it on. So 25 or 22. That's reading 20, 1.47 ohms. This one, 1.56 ohm, it's reading 10. So that's pretty much bang on, just over 10. And the big one, that's reading 0.56 or 46.66, so it's just slightly under 47. Well, they're a lot better than what we had. So I'm happy to go with that. So let's get the heat shrink to turn the tester off, because the batteries are quite expensive and I haven't got any spares. I usually have a few knocking about, but I haven't. So we're going to use the heat shrink. Go a bit lower than that because I want to take this down as low as I can to the board. So if I bend that over like that, just heat shrink that on. There we go. That's one done. Because that should be always okay. The next one is that one, and chop that down a little hair down, and chop that down a mouse's midge. There we go. Probably going to stand a bit proud of the board, this one. Go a little bit further. I can always put another piece on, I'm not sure of heat shrink. Yeah. Go with another piece, I'm not completely happy. Oh, hang on. Let's try this piece here, because this is a good half. No. Save them bits though, because they come in handy. I reckon that piece there will do it. Yep. Shrink it down. You notice I use the iron, the body of the iron and not use the blade. Don't use the tip of the iron. The reason why I don't do that is because you get bits of solder coming off the blade, or coming off the tip rather, of the iron blade. What the fuck am I thinking of? Coming off the tip, so, and that there is, you know, and you could potentially get a short, so I tend to use the tip. I tend to use the body of the iron rather than this piece here. Might work on this piece. Yeah, it will. Cut it down to the length needed, and I think that should be about bang on, unless I've been too big-headed and done it too short. Bend that slightly over. There we are. We have our replacement capacitors made up. There we go, folks. Just shrink that one down there a bit further again, but try and get a bit more of a tighter fit. There we go. That should stay there. Oh, easily. Easily. Yeah. Right. So let's take this off here because I've got a feeling I'm not going to need it. Now, I'm going to have my fag, and then when I come back we'll get the capacitor soldered in. Right, let's get this heat shrink out of the way for a minute. Now let's get this capacitor pack fitted. And so it went that way, and it's easy to see which is the square. The HC goes to it, so it goes in. So it's square, triangle. The triangle's on the wrong side. The one for the triangle's on the wrong side. I'm going to move them round. So the square, square, triangle, blank. I should have put the blank on this side, can I not? Yeah, I might be able to just get it under here, because it needs to be this side. There we are. Yeah, that's sorted that out. There we go. Yeah, just clean that flux off there. There we go, that's only flux. Yeah. So we need to, so triangle, so square, triangle, blank, as it's written. There we go. Oh, I've not shrunk that one. Want it falling off, do we? Or there we are. Now let's get this in. So shove that under there if I can. Just hold it stable. No, where's my solder? There it is. Oh, I've got a piece here still. Let's use that piece there. Probably got to get it with this one piece. There. Put that under there. Just put that under that. There we go. Get the little, you just heat it up, press it down, we'll get a good connection. There we are. There we go. Lovely. That's one on. Do the next one. Yep. We have them in the right places. Just reinforce that one a little bit. There we go. Okay. So we have all the negatives tied together. We have the 400 volt 10 UF, which is that one, which is the 16, which is 2 for 275. The 32, which I've put in the 48, which is the 450, which goes to the HT, which is the one that the rectifier, positive of the rectifier goes to. The rectifier goes to here. Then we have, just clean this pad up here a little bit. There we are. And all I need to do now is join these three pads up. these grounds, or two of them anyway. The third one I don't think it goes anywhere. The third one doesn't lead anywhere, so I don't have to worry too much about that. So what I'll do, I will feed the grounds through the one that isn't being used, because that one's not being used. So just strip the wire down a bit more, can't get to it there. And I think I've overdone that. Yep. I'll have to join that, because getting that off will be a nightmare. I've overdone it. There we go. Get a bit more wire. Wish I had that piece I had last night. It was really good wire. There we go. That's got it. Twist that round. Twist that round. Join that onto there. Yeah. Easier said than done. Yeah. That's better. A bit more wire to play with. Join them together. That's better. Yeah. I think that one there's a bit short. Just, there we go. Ah, yeah, bastard. I unrolled it. That one there's a bit short, but I can't get it any longer. But I do want a mechanical connection. There we are. There we go. That'll do. A bit of solder. Oops, nearly knocked my cup over. That reminds me, I'm due a coffee soon. Just solder that. Sure don't drop anything down the valve socket. Oh, it's come off, you fucker. We'll just hold them together. shrink. That might be too thin. Yeah. Put that one there. That's the one. No, it ain't. That's it. That sharp point there, just flatten it down with the pliers wherever they are. There they are. Squeeze that down. Just try and clip that. I don't want it coming, I don't want it penetrating. Pull that off for a minute. That's got it. Lovely connection there. It's a good winding round. We'll tin it when we go through the hole. That way we can make sure it fucking fits. Pull that down to there. Shrink that down. There we go. Feed that through the hole, and the hole we're not using, which is that one, which is the one we'll feed it through. Doesn't matter if it gets a bit ruckled. There we go. There we go. Let's get that tinned. Now let's have a look where we want to route it. So we want to go there to start with. So put a blob of solder on there. And then we need to go across with some heat shrink. think. That one will do. Chop it down a bit because it's too fucking long. Start there and see how we go. Still too long. Like that. And I look at my eye. There we go. Now bring this across. Just heat shrink it first. There we go. The iron are clean. Always keep your iron clean. Now, put a blob of solder on what used to be the square, or the oblong rather, this one here, which was the, or the ring as they call it. There we go. And then just bring, I don't want to stretch it, so what we'll do now, we'll curve, shift that, curve our wire. Put a nice curve in it so it's natural, so it doesn't want to spring. Solder that to there. There we go. Just hold it up a bit and do it again because we want it as far away from the positive as possible. And there we go, folks. Yeah, lift that off there. We're okay there. What I'll do now, I'll rest this on here. And I'll now go around with my test meter. Check we've got what we should have. Make sure we've got no shorts. We don't want shorts. So, just put the black into there. Turn this so you can see it. Shift that out of the way. Yep. Yep. I mean, I could have just actually, I mean, really, I didn't have to, well, I had to bring it from the capacitor, so that's why I brought it through that hole there, and that hole isn't used. So we've got a ground here, a good ground here. No short there. No short there. No short there. And everything's soldered in. So all soldered nicely. Yeah. Go over this with the ESR tester. I bet it tells me that one of them's in circuit leaky. We know they're all okay, but just out of interest. So what we'll do, we'll connect our negative to there. We'll turn on our capacitor tester. Yep, 47.62 it's reading this time. It come up with low battery then as well. Yep, 10.54. And this one. In circuit leaky. So that must be going. That goes to there. We know it's not leaky. We know it's not. It goes to this valve pin here, but it also goes to this resistor here. Goes to this resistor, and we want to check those resistors next. One should be 120 ohm and the other one, well, I think it should. 134. And 4.2 K. I think that should, yeah, it's right, that 4.2 K. So we're okay with that. I'll double check it against the manual because I'm useless at these rings. The next one we want to do, I need to look at getting a new battery for that because it did give me a warning. Sit them up so they're nice and straight. Come on, sit up. There we are. So they're nice and straight. That's the capacitors done. Just clean this valve socket. All we do there, just spray a bit of cleaner into it. There we go. Pop the valve in and out a couple of times. And I've just managed to rub what said EL84 off, and well, no, actually I haven't, it's still there. Bet that girl's name's come off now. No, it's still there. No, it's still there, surprisingly enough. Hang on. I'm going to go and get myself a cup of coffee, folks. I'm going to call it, I'm actually going to call this part, this is part 2. Join me for part 3 when I'll be putting the amp and everything back together. We've got the capacitor done.